Oh yes, Evan, and welcome to this quick binary recap session. So, um, what on earth is binary in case you've forgotten? Binary is how computers store data, and they do this using the digits 1 and 0. Because you have to remember, computers do not understand English, French, Spanish, Chinese. They can only understand ones and zeros. Um, so, um, binary means two parts. So the two parts are 0 and 1. It can also represent on or off. So 1 represents on and the 0 represents off. So inside a computer, there are loads of little circuits and these little wires connecting bits together. And computers look at that and go, if it's a 1, that wire's turned on. If it's a 0, that wire's turned off. So binary isn't just data, but it's also controlling the circuits as well that move around the computer. And so binary is a number system that only uses two numbers, like I said before, 0 and 1. It might seem binary can also represent any number in the world. It might sound a bit strange at first. You're thinking, how does 0 and 1 represent 2 million, for example? But it can. I'm going to look at a few examples today. So, we are going to convert decimal to binary. So, decimal numbers are your numbers we use every single day 8, 9, 10, 5, 4. All those numbers are decimal. And we're going to convert that into binary. So when we're doing that, when we're converting decimal to binary, we need to create a table that looks similar to that. That looks like this. One thing you might notice about these numbers at the top here, 1, 2, 4, and 8, each time they are doubling. Yeah. And we always start from the right. So 1 goes there, 2, 4, 8, 16, 32, so on and so on and so on. So each time we're doubling this number because 8 double 8 is 16, double 16 is 32, double 32 is 64, so on and so on and so on. So we've got number 5 here. Our number is 5, and we need to put this into binary. So we need to ask ourselves how many 8s fit into 5. None. So 8 does not fit into 5. So in that column, we put a 0 to represent off or false or whatever. Then again, how many 4s fit into 5? 1. Perfect. So 1 4 fits into 5. And then what we need to do, though, is take away 4 from 5. So 5 take away 4, which is 1. So we're left with 1 now. And we start the process again. How many 2s fit into 1? None. 2 don't go into 1, does it? So there's a 0. And same again. How many 1s fit into 1? 1. Perfect. So you put 1 there. And that 0, 1, 0, 1 is how a computer reads the number 5. So when you type number 5 on your keyboard, the computer sees 0, 1, 0, 1 instead of the number 5. Because it doesn't understand 5. All right. So you can also check the answer's correct by looking at our number was 5 originally. You'll see at the top there's 4, and that's 1, isn't it? So there's 1 in 4, and there's 1 in 1. 4 add 1 is 5. That represents that. All right, let's do a few examples together in case we're a little bit, oh my God, what you bang on about, sir. So our number is 6. We need to put number 6 into binary. So again, ask ourselves, how many 8s fit into 6? None. Perfect. So we put a 0 here because 8 does not fit into 6, does it? All right. How many 4s fit into 6? 1. Perfect. So now we have to take away 4 from 6. So 6 take away 4 is, what is it? 2. Perfect. 2. So, and ask ourselves again, how many 2s fit into 2? 1. Perfect. And we do it again. We don't need to split self-pointing, but 2 minus 2 is 0. That means anything else we've got left here is going to be 0. So the number 6 in binary is 0, 1, 1, 0. And you can check it's right again by looking where the 1 is, looking above it. So that's 4, and that's 2. 4 out of 2 is 6. All right, let's do one more with us then. So 1, 2, 4, and 8. Remember, these are doubling each and every time. So if we take the number, we'll do 11. We'll try 11. So 11 is our number. We need to put 11 into binary. Sorry about the wonky 4 here. I apologise. So 11. Ask ourselves again, how many 8s fit into 11? 1. So we put a 1, so 8 does fit into 11. Then we need to do 11 take away 8. And 11 take away 8 is 3. Perfect. So once we've got that, we need to look at, so this, our number now is 3, not 11 anymore. We've got 3 now. That's our number. So how many 4s fit into 3? None. Perfect. 4 does not fit into 3, does it? So we put a 0 there. So we've still got 3. How many 2s fit into 3? 1. Perfect. So you put a 1 here. Do 3 take away 2, which is 1. Perfect. So now we're left with number 1. So 1s. How many 1s fit into 1? 1. And we've got nothing left now, have we? 1 take away 1 is 0. So number 11, just started with here in binary, is 1, 0, 1.